In this section, we're going to talk about a new thing called a series. Now, a series is a sum of an infinite sequence. So in the last lesson, we talked about what a sequence was. Okay, we describe or define a sequence using this notation, a sub n. And if we want to write an infinite series, we're going to write it as a summation, which we've seen before with integrals. And so this is a sum of the terms of a sub n. So if we take a sub 1, a sub 2, a sub 3, again, we're saying these are subscripts, all the way up to a sub n and on to infinity. If we add those up, that's what the definition of the series is. Okay. Now, in order to get a handle on this, we're going to need to look at what we call the partial sums. The partial sums are what we get when we just add a few of the numbers together. So we'll say S1 is what we get when we add the first number together. S2 adds the first two terms, A1 and A2. S3 adds the first three, so on and so forth. So if we have S sub n, then that will add up the first n terms in the series. So the partial sums will help us to get a handle on what's going on. All right, so there's our definition of the nth partial sum. It's just adding up the first n terms. Okay, now if we look at the sequence of partial sums and those partial sums converge, then that means the whole series will converge. So if it converges to S, okay, then the series we can say converges. Remember, the series is infinite. Okay, so the limit S is called the sum of the series. In other words, that number S is what the summation is worth. So if S sub n diverges, then the whole series diverges. If the partial sums start blowing up, then that means the whole series blows up. So what do we get if we find a pattern like this? 0.1 plus 0.01 plus 0.001, so on and so forth, okay? Now, if we were able to write this out an infinite number of times, what would it add up to? Well, in order to figure that out, we're going to look at our partial sums. So S sub 1, that is just adding up the first number. That is 0.1. S sub 2 is adding the first two numbers, and that is 0.11. S sub 3 is adding up the first three numbers. So if you add up the first three numbers, you're going to get 0.111. And I think we can see the pattern. S sub 4 is going to be adding up the first four numbers. 0.1234, okay. All right, so S sub n would just have 0 and it would have n ones. Okay, that's how many ones it would have. Those are all ones. Okay, so that's the idea, all right. Okay, so the question now is, what's this summation? All right. Well, do you recognize this number? It's 1 repeating. So the limit of these is our sum, and the sum is 0.1 repeating, and that is a fraction we call 1/9. Okay. So 1/9 is 0.1 repeating. All right. How about this one? Now, you might pause this and give it a try here if you haven't thought about these. See if you can find the pattern in the partial sums. So, S sub 1, first one is 3/10. S sub 2, add up the first two. Well, we need to make this into hundredths. So, times 10 on top, times 10 on bottom, that would be 30 hundredths. Plus 3, that would be 33 100ths. S sub 3 is going to be, turn them all to thousands. Multiply this by 10, multiply this by 100. You'll have 333 thousandths. And do you see a pattern? It might help if you put it into decimals. This is 0.3. This is 0.33. This is 0.333. Okay, so S sub n is going to have 0.3. It's going to repeat, and we're going to have n of those. Okay, so what is this getting closer to? Well, it's getting close to 0.3 repeating. So the sum is going to 0.3 repeating. And do you recognize 0.3 repeating? Well, that's 3/9 or 1/3. Okay, kind of hopefully familiar. Probably seen that in the past. What about this one? So if we add this up, s sub 1 is 1, s sub 2, we got to get a common denominator, 2 halves and 1 half, that's 3 halves. Adding the first 2, adding the first 3 would be getting it into fourths, so 4 fourths plus 2 fourths plus 1 fourth, that would be 7 fourths, s sub 4, and that's going to give us 15/8. So on and so forth here. Maybe go one more. S sub 5, that is giving us 16ths, so it's going to be 31/16. Okay, well, what's going close? What's happening here? Well, this top one is almost doubled the bottom. Okay, it's going to be 2 times the bottom minus 1. So as this gets infinitely bigger, the top is basically twice as big. So the limit here is 2. So the infinite series adds to 2. Okay. All right, one more here. What's going on here? Well, if we convert these to decimals, we get this. S1 is 0.15. S2, add these two up, is 0.1515. S sub 3 is 151515. All right, so S sub n is going to be 0.15 repeating, right? Okay, actually, it's going to not be completely repeating because it's going to be in pairs, right? So 1515, and that'll be in pairs of one fives. Anyways, so what's that going to there? Well, the limit is what this is going to is 0.15 repeating. And I'll show you a real quick technique here. What is that as a fraction? 0.15 repeating. Well, 0.15 repeating is 0.151515 repeating. Okay. And let's say, I don't know what that is. Let's call it x. Well, if I multiply both sides of this by 10, I got an equation here. Multiply both sides by 10. That's going to move the decimal 2 places. That's 15.151515. And now I have a system of equations. If we subtract these two, well, these are going to go away. And I'm left with 15. And I have, you know what? Actually, back up. I need to multiply that by not 10, but I actually multiplied it by 100. I moved the decimal 2 places. So I had to multiply it by 100. Okay, that moves it 2 places. That's what we did there. So multiply both sides of this by 100. Moves decimal 2 places, we get that. So 100 minus 1x, that'd be 99x. And if we solve that up, divide by 99, we get 15/99. Kind of cool. So x, the number we started with, is 15/99. That's what it is. That's the sum. That's the limit there. All right, so that gives a quick idea here of what partial sums are and how we can get if we find a pattern in the partial sums, we get the summation S. So now let's look at some series here that aren't written out. So we have to write them out ourselves. Okay, so here's the summation notation. So we're going to plug in 1 and we get the first term. So this is equal to 1/2. Plug in 2 and we get 1/2 squared. That's 1/4. Plug in 3 and we get 1/8, 2 to the third, 1/16, and so on and so forth. Okay, so we're plugging in 1, 2, 3, 4 into n. That gives us the term, and then remember the series is what we get when we add this up. Okay, so what do we get when we add the first one up? We get 1/2. what do we get when we add the first 2? Well, that's 1/2 plus 1/4, that's 3/4. Add the first 3, we get 7/8, and maybe one more just for kicks. Add the first 4, we get 15/16. Can you tell what's going on here? These are powers of 2 down here. So we have 2 to the first, 2 to the second, 2 to the third. So the bottom is 2 to the nth, and the top is 1 less. Okay, it's always 1 less than what the bottom is. Okay, so the question now is, does this converge? Well, do you know what the limit is of 2 to the n minus 1 all over 2 to the n? Well, as you go to infinity, this 1 doesn't matter. It's 2 to the n over 2 to the n, and so this limit is 1. So this converges. Okay, we can just kind of always tell logically that it's always going to be 1 less on top. It's going to get real close, and so this is going to 1. Okay, what if we just have the sum of 1? Well, this means the first term, when you plug 1 in for n, well, there is nowhere for n, so the first term is 1. The second term is, when you plug in 2, it's 1. And the third term is 1, so on and so forth. Because there's nowhere to put the n in, so it never changes. It's a constant sequence. So now let's add up the series here. Add the first one up, you get 1. Add up the first 2, you get 2. Add up the first 3, you get 3. Add up the first n numbers, you get n. Well, as n gets larger and larger, what's the limit as n goes to infinity of n? So as n goes to infinity, this sum goes to infinity. So this diverges. It doesn't go to a finite number. All right, one more here. Okay, so here we have a series. The first term, when you plug in 1 here, you're going to get 1 over 1. Right, it's 1 over 1 minus 1 over 2. That's a half. Plus, plug in 2. We get 1 over 2 minus a third. Plug in 3. We get 1 over 3 plus 1/4. Actually, it's going to be minus, right? All right, let's clean this up. What do we get here? We get 1 minus a half is 1/2. 1, okay, got to get a common denominator here. This is 6. This is 3/6 minus 2/6, so this is 1/6. Common denominator here is 12, so this is 4 minus 3/12, so that'd be 1/12. So on and so forth. Now, if we add these up, the first one is a half. If we add the first 2 numbers, let's see, what's that going to be? That's going to be 3/6 and 1/6. That's going to be 4/6. Add up the first 3 numbers. So when you get them all to twelfths, this is 6/12, 2/12, and 1/12. 6 plus 2 plus 1 is 9/12. Ooh, do you recognize those numbers? 1, 4, 9. So it looks like the top is a square number. So this is n squared. You see that? 1 squared, 2 squared, 3 squared, n squared. And the bottom is what we call a oblong or a rectangular number. This was 1 times 2, 2 times 3, 3 times 4. So it's going to be n times n minus 1. Actually, n plus 1. Okay, there we have it. So now the question is, does this have a limit? So what's the limit as n goes to infinity of n squared over n times n plus 1? Well, let's clean that up a little bit. That's the limit as n goes to infinity of n squared over n squared plus n. Now notice they're both squared functions, quadratics that is, second degree. As n goes to infinity, well, in the bottom, this smaller degree is not going to matter So it's n squared over n squared. Well, it looks like this thing is going to 1 also. So this converges to 1.